sofa, my tucked in. Right, draw your favourite sofa again. Just a good question to start with. Does anyone remember the name of the unit?
It's
our Jamie, Peripherals. Right, what do we start off with in Peripherals then?
interface.
Yeah, interfaces. So we defined interfaces as what? What is an interface?
Hardware and software required for communication between the processor.
Well read. Hardware plus software to allow communication, to allow comms. Yeah, so we talked about 5 different functions of interfaces after that. And we come up with the stupid phrase, which was what, to help us remember them all. What was it, Andy? Jamie. Puppy dogs bite very hard. Right, which gives us the actual functions of the interface, which are what? Awesome, protocol conversion. Now, what was the 2 protocols that we spoke about that we might need to convert between?
A to D and D to A.
Nah. Nah. So the protocol will be how it transmits data and how they set up and speak to it. Yeah, so it's parity, so odd and even parity. Brilliant, so that's protocol conversion again. The interface's job there is to connect, or sorry, allow the 2 to communicate, allow the 2 different devices to communicate, especially when they send data using different protocols. That's not the only 2, it's just examples. The dogs will be for which one?
Data format.
Yeah, data format conversion. And this is the one Caleb was talking about, so it's the 2 formats then, Ross, that we convert between. Yeah, so we get analog to digital, A to D, and we get D to A. It's a favourite question they like to ask you about if it's a CD player. Which one of those 2 would it have, a CD player? Chrissy? Which would a CD player have?
Digital.
Digital analog. Why would we hear sounds as? Do we hear digital or do we hear analog?
Yeah.
Right, we hear analog signals, don't we? And the CD stores it as digital. B for byte. Buffering, right, we'll come back to that one because there's a lot more to it. Buffering. Right, so maybe you come back to that. Vary. Voltage conversion, yes. Voltage conversion. Karen, why do we need voltage conversion? Great. Caleb?
So the motherboard is like.
Yeah, why?
Because it only needs a small amount of voltage. Other peripheral devices require a lot more.
Good answer, yeah. So the motherboard's got really small components that if they get hit with the full voltage for the mains and for the other peripheral devices, it would fry all the really small components in it. Voltage conversion, the same the other way around. The signals sent out from some of the smaller components won't be strong enough for other devices, so it needs to be stepped up or stepped down accordingly. H, handling of status signals, brilliant. Handling of status signals. Right, we'll probably get asked for a couple of examples of them, so forget all the joke Facebook ones we said. What are some proper statuses that peripheral devices will go into? Ready. What else? Busy, yeah. Any particular for a printer, for example? Right, so busy, that would be printing. What other states can we get? Jam, yeah, out of paper, so jam, out of paper, out of ink, so on. So let's us add other devices, try to communicate with it, know if it's available or not. Right, so we talked about buffering, which was what? What is buffering?
Temporary storage.
Good. So temporary storage of data. Why do we need to temporarily store it if we're just trying to send it to a peripheral?
It's glistening and stuff, but the peripheral can only handle it at a certain speed, so if it sends it out at a speed the peripheral can manage.
Good, good. So it's allowing the processor to send data really quickly to a temporary storage location so it gets done and it's move on to the next task. And then that allows the peripheral device just to go and speak to the buffer and take it for there at a speed it can cope with. Right? Because remember we're talking about these functions of interfaces compensating for the differences in characteristics, differences in the speeds, differences in the data formats they work in. So that's one of the functions of an interface. We talked about something else that's also temporary data storage. Spooler, awesome, spooler. And we talked about the similarities and the differences between buffers and spoolers. You know, tell me anything similar and different from them.
Spoolers hardware.
Yeah, so spoolers are hardware, or is it?
Oh, spooler software.
Yeah, that's the software-based solution. And the buffer's the what?
Hardware.
Hardware. So where would we find the buffer if we were looking for it? If it's I've talked about printers here and scanners, keyboards, where are they going to be, the buffer? Are they going to be in your laptop that's sending out the data, or are they going to be somewhere else?
They're going to be in the keyboard.
Yeah, they're going to be built into the peripheral device themselves. The spooler is a software solution which uses what? Because it's a bit different. It doesn't use a buffer, it doesn't use the peripheral device to store it. Where does it store data temporarily? The hard disk, yeah, and a fast backing storage. So, which one is going to give us a much larger capacity, do you think? The spooler, yeah. So we can put a wee positive on that. It's going to have a larger capacity. Now in real life, both of them are used. There's not like a pick one or the other. The buffer is going to be in your peripherals anyway. But the spooler's another option there, usually over like a print server would be set up to store stuff in a spooler, especially maybe at a home network. One computer would act as a server. So you'd want one that's got a lot of backing storage if it was going to act as a print server. There's not much more we talked about actually in this. We talked about a couple of different things. What was the next wee research task we did after that to do with storage? Anything about storage, particular storage? We did talk about the developments in it, we'll talk about that in a second as well.
Solid state.
Yeah, we talked about solid state devices first of all, didn't we? So we talked about solid state devices, or SSD. So they're becoming more mainstream now. We get them in all devices. Why are we getting them in devices? What's some of the advantages of them?
Small.
Yeah, so they're becoming. Why are they smaller? What, in fact, why are they called solid state? First of all, that's important. Yeah, so no moving parts. So therefore, they can be smaller compared to older moving hard disks. They've got a head that has to move on them. They're spinning. What else would that mean then? There's a couple of more advantages, yeah. Quieter, because there's no moving parts as well, yeah, quieter. If there's no moving parts to power, more robust, that's a good one, buddy, because there's no moving parts, robust. What about in terms of having to power it? Yeah, less memory. Less electricity, your battery lasts longer, yeah, so less power we'll put in there, just remember to explain that one. Less power required, so they'll last longer per charge, no moving parts, more robust. Our devices are getting much smaller because the memory that we put into them is becoming much smaller as well, so things like cameras, laptops all getting smaller and lighter. Then we talked about developments for a few different things. Yeah, oh god, I can't spell it. So we talked about the developments in back-end storage, the trends. If they buy a laptop or a camera just now, 6 months' time, all of these things would be better in it. So what's some of the things that would have changed? Yeah, so capacity increased. What else? Yeah, so cost per bit goes down, or you're getting a larger capacity for the same price. Anything else? Yeah, increased data transfer speed or read-write speed. Increased data transfer rate. Physical size? Smaller, yeah, so smaller physically. Right, and else talked about? We talked about the same developments and I guess interfaces just as well. So what's the latest interface called in the iPhones, etc., and iPods? And remember what it's called? Or what connection do you use on the Android devices?
USB 3.
Yeah, so they'll get USB 3, which ages ago was just USB, I mean it was called USB 1 actually, and then another one's called Lightning Bolt, or something like that. I think this is Lightning maybe. Is it Lightning Bolt?
Lightning.
It's just Lightning maybe. Okay, that's not important. What's the trends with them? What's happening with the interfaces in terms of
Physically getting smaller.
yeah, so the devices I suppose are getting smaller, but in terms of how much data and how quick the data goes.
Transfer a little faster.
Yeah, so this is true. Increased transfer rate, and the capacity that they can transfer at the same time is obviously increasing as well, so you get faster speeds and can carry more. There's one other bit that I think we've missed that I can't remember if it was in this unit or not. One you all probably ate for breakfast this morning. So I had porridge though, so I was lying. Yeah, did we talk about that in this unit? It was this unit, wasn't it?
Yeah, it was.
So that's to do with data transmission. So what's the two different types? Serial, parallel. So think of the parallel bars event at the Olympics. If nobody's watched it, just remember that a serial killer kills one person and then moves on to the next one and blah blah blah. And it's the most normal people that turn into serial killers as well. What is serial better for? Send stuff faster. But there's more wires there, would that not be faster? One's better over longer distances, one's better over shorter distances. Which one?
Serial's better over longer.
Yeah, serial's better over longer distances. And this one's faster over shorter distances. And it's just to do with checking the bits. How would you describe serial? How many wires?
One.
One wire. So how many bits can it transfer at a time?
One bit.
Yeah. One bit at a time. Many wires would be in parallel? Multiple, yeah, don't worry about counting them and naming a specific amount. Multiple wires, how many bits then? Yeah, multiple bits. There's one other word we need to talk about there though. Simultaneously, yeah. Simultaneously. Because this one's capable of transferring multiple bits, just does them all individually. It's multiple bits on multiple wires at the same time with this one. And again, if it's two peripherals communicating, what would it send back to let it know it's been received correctly?
Ready signal. Ready signal.
Yeah, ready signal, ready to see the next one, or a signal of status saying it's been received correctly, or a status sent back to say it's not been received correctly. Can they resend it? Now, it's a pretty short topic, and we tend to ask a lot on solid state devices, advantages. This question comes up all the time about drawing the diagrams and explaining the differences. You're definitely going to get asked some of the functions of interfaces, so it's worth knowing loads of it. In fact, it's that short that I can pretty much picture every part of it coming up. This part will always come up, comparing the difference between a buffer and a spooler, what's the differences and similarities. And I don't think there was anything else. Anything we've missed? No, again, there's nothing here at all. The only other one we did talk about was the wireless connections. What's the different wireless connections we spoke about? Wi-Fi, Bluetooth, and then the old one. Infrared, which has got the largest distance of large. Wi-Fi can transmit over large distances. What's the kind of trends happening with them? Yeah, the transfer speeds are faster as well as the range. Yeah, much increased range we get over them. What does Wi-Fi stand for? Wireless.
Wireless.
Fidelity.
Damn it, where is it?
Starts with an A.
Why?
Alliance. They'll probably not ask that stuff right enough, but that's that.